Picture this, a vast, endless expanse of darkness, dotted with countless stars, each one a sun to its own world. Somewhere out there, in the infinite reaches of space, objects are traveling, not from our solar system, but from distant stars, far beyond what we can see. These are interstellar visitors, mysterious travelers from other star systems, passing through our cosmic neighborhood. What are they? Where do they come from? And what secrets do they carry from the far corners of the universe? Tonight, we embark on a journey to uncover the story of these enigmatic wanderers, the interstellar objects that have captured the imagination of scientists and dreamers alike. As we drift into the quiet of the night, let your mind wander with us into the depths of space where the unknown awaits. Where are you joining us from, and what time is it there? Let's begin this journey together as we explore the search for interstellar objects, visitors from other star systems. Now, let's take a closer look at what interstellar objects actually are. Unlike the comets, asteroids, and planets that orbit our sun, interstellar objects are cosmic travelers that originate from outside our solar system. They are not bound by the gravity of our sun, and instead, they journey through the vastness of space, passing through our solar system on their way to who knows where. These objects are like cosmic nomads, carrying with them the secrets of distant star systems. So, what makes them different from the objects we're used to seeing in our own solar system? For one, their origins are far more mysterious. While most objects in our solar system formed from the same swirling cloud of gas and dust that gave birth to the sun and its planets, interstellar objects come from entirely different star systems. They could have been ejected during the chaotic formation of planets, or perhaps they were flung into space by the gravitational pull of a passing star. Whatever their origin story, they bring with them a unique snapshot of the conditions and materials found in other parts of the galaxy. When it comes to their composition, interstellar objects are just as intriguing. Some, like the first known interstellar visitor, Oumuamua, appear to be rocky or metallic, while others, like Comet Borisov, are icy and resemble the comets we see in our own solar system. This diversity suggests that the processes that create these objects are not so different from those in our own cosmic backyard, but the specifics of their makeup can tell us a lot about the environments they came from. The significance of their journey through space cannot be overstated. These objects are like messengers from distant stars, offering us a rare opportunity to study materials that have traveled light years to reach us. By analyzing their composition and trajectory, scientists can piece together clues about the conditions in other star systems, and perhaps even uncover evidence of how common or rare planetary systems like ours might be in the universe. As we continue to explore the mysteries of interstellar objects, one thing becomes clear: they are more than just fleeting visitors. They are windows into the vast, interconnected tapestry of the cosmos, reminding us that our solar system is just one small part of a much larger story. And with that, let's turn our attention to the first known interstellar visitor, Oumuamua, and the fascinating questions it raised about these cosmic wanderers. Now, let's shift our focus to the first known interstellar visitor, Oumuamua, a discovery that captivated the world in 2017. This mysterious object was first spotted by the Pan-STARRS telescope in Hawaii, and its arrival marked a historic moment in astronomy. Unlike anything we had seen before, Oumuamua was not bound to our solar system. Instead, it was a fleeting guest, passing through on its way to parts unknown. What made Oumuamua so extraordinary was its unusual shape. Unlike the round or lumpy objects we typically see in space, Oumuamua appeared to be elongated, almost like a cosmic cigar. Estimates suggested it could be up to 10 times longer than it was wide, a shape that sparked endless curiosity and debate. How did it form? Was it a fragment of a larger object, or did it take on this shape through some unknown process in its home star system? Its trajectory was equally puzzling. Oumuamua didn't follow the smooth, predictable path of most comets or asteroids. Instead, it seemed to accelerate as it moved away from the sun, a behavior that left scientists scratching their heads. Some proposed that outgassing, the release of gas as the object warmed, could explain this acceleration, much like how a comet's tail forms. But Oumuamua didn't show the typical signs of outgassing, such as a visible coma or tail. This led to even more speculation, with some daring to suggest that its acceleration might hint at something far more exotic. The scientific debates surrounding Oumuamua were as intense as they were fascinating. Was it a natural object, or could it be something artificial, like a probe sent by an advanced civilization? While most scientists lean toward natural explanations, the possibility of an artificial origin captured the public's imagination and fueled countless discussions. What we do know is that Oumuamua offered a tantalizing glimpse into the diversity of objects that exist beyond our solar system. Its brief visit left us with more questions than answers, but it also opened the door to a new era of interstellar exploration. As we continue to study this enigmatic visitor, one thing is certain: Oumuamua has forever changed the way we think about the cosmos and our place within it. With that in mind, let's turn our attention to another interstellar traveler, Comet Borisov, and see how it compares to the mysteries of Oumuamua. Now, let's dive deeper into one of the most puzzling aspects of Oumuamua's journey: its unexpected acceleration. As this interstellar visitor sped away from the sun, something unusual happened. Instead of slowing down, as most objects do when they move farther from a gravitational pull, Oumuamua seemed to speed up. This behavior defied the laws of physics as we understand them, leaving scientists scrambling for explanations. One of the leading theories to explain this acceleration is outgassing. When comets approach the sun, they often release gas and dust as their icy surfaces heat up, creating a glowing coma and a tail. This process, known as outgassing, can act like a natural thruster, giving the comet a slight push. However, Oumuamua didn't show the typical signs of outgassing. No visible coma or tail was detected, which made this explanation less straightforward. Some scientists suggested that perhaps Oumuamua's outgassing was subtle or occurred in a way that wasn't easily observable, but this remains a topic of debate. Another intriguing possibility is that Oumuamua's acceleration was caused by radiation pressure from the sun. Light exerts a tiny but measurable force on objects, and for something as thin and elongated as Oumuamua, this force could have been enough to nudge it along. However, this theory also has its challenges. For radiation pressure to account for the observed acceleration, Oumuamua would need to be extremely lightweight, almost like a sheet of paper, which raises more questions about its composition and structure. Then there's the more speculative idea. Could Oumuamua's acceleration hint at an artificial origin? Some scientists, including Harvard astronomer Avi Loeb, have proposed that Oumuamua might be a piece of advanced technology, such as a light sail designed to harness solar radiation for propulsion. While this idea is far from proven, it captures the imagination and reminds us of the vast possibilities that exist in the universe. Of course, most researchers lean toward natural explanations, emphasizing that extraordinary claims require extraordinary evidence. But the mystery of Oumuamua's acceleration highlights how much we still have to learn about the cosmos. It challenges us to think beyond our current understanding and consider new possibilities, whether they involve natural phenomena or something beyond our imagination. As we continue to study Oumuamua and other interstellar visitors, one thing is clear: these objects are not just passing curiosities. They are windows into the unknown, offering clues about the processes and materials that shape other star systems. And with each discovery, we come one step closer to unraveling the secrets of the universe. With that in mind, let's turn our attention to another interstellar traveler, Comet Borisov, and see how it compares to the mysteries of Oumuamua. Now, let's shift our focus to another fascinating interstellar visitor, Comet Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov. This object became the second confirmed interstellar traveler after Oumuamua. Unlike Oumuamua, which left scientists puzzled with its unusual shape and behavior, Comet Borisov looked and acted much more like the comets we're familiar with in our own solar system. Comet Borisov had a distinct coma, a glowing cloud of gas and dust surrounding its nucleus, and a long, flowing tail, both of which are classic signs of an active comet. These features made it easier for astronomers to study and classify, as they could use well-established methods to analyze its composition and behavior. Observations revealed that Borisov was rich in carbon monoxide, a common feature of comets, but its levels were significantly higher than those found in most comets from our solar system. This difference hinted at the unique conditions of its home star system, offering a glimpse into the diversity of cosmic environments beyond our own. Another key difference between Borisov and Oumuamua was their trajectories. While Oumuamua's path through the solar system was unusually elongated and fast, Borisov followed a more predictable, hyperbolic orbit. This made it easier for astronomers to track and study over a longer period, providing valuable data about its structure and composition. For instance, scientists were able to determine that Borisov's nucleus was about half a mile wide, making it larger than Oumuamua, which was estimated to be only a few hundred feet in length. Perhaps the most striking aspect of Comet Borisov was how much it resembled the comets we know, despite its interstellar origins. This similarity raised intriguing questions about the universality of comet formation. If comets like Borisov can form in other star systems under conditions similar to those in our own, it suggests that the processes shaping planetary systems might be more universal than we once thought. At the same time, Borisov's differences, like its high carbon monoxide content, reminded us that every star system has its own unique story. By studying these interstellar visitors, we're not just learning about individual objects, we're piecing together a broader picture of how planets, comets, and other celestial bodies form and evolve across the galaxy. As we continue to explore the mysteries of interstellar objects, Comet Borisov stands as a reminder that the universe is both familiar and strange. It challenges us to expand our understanding, while also reinforcing the idea that the cosmos is full of surprises waiting to be uncovered. With that in mind, let's turn to the tools and techniques astronomers use to detect these fleeting visitors, and how they're working to uncover even more interstellar secrets. Now, let's take a closer look at how astronomers actually detect these elusive interstellar visitors. Spotting objects that come from beyond our solar system is no small feat. These travelers move incredibly fast, often passing through our cosmic neighborhood in a matter of weeks or months. So, how do scientists manage to catch them in the act? The first line of defense in this cosmic hunt is ground-based telescopes. These powerful instruments scan the night sky, capturing vast amounts of data as they search for anything unusual. When an object moves in a way that doesn't match the predictable paths of asteroids or comets from our own solar system, it raises a red flag. This is exactly what happened with both Oumuamua and Comet Borisov. Their unusual trajectories caught the attention of astronomers, who then focused their efforts on studying these strange visitors more closely. But it's not just about spotting the objects, it's also about tracking them. Once an interstellar object is detected, astronomers use a combination of telescopes and advanced software to monitor its movement. This helps them calculate its speed, direction, and even its size. For example, the Pan-STARRS telescope in Hawaii played a crucial role in discovering Oumuamua, while smaller observatories around the world contributed to tracking Comet Borisov. One of the biggest challenges in detecting interstellar objects is their speed. These visitors are often moving at tens of thousands of miles per hour, which means they don't stay in our solar system for long. By the time astronomers notice them, they're already on their way out. This makes it essential to act quickly, gathering as much data as possible before the object disappears from view. Another challenge is their size. Many interstellar objects are relatively small, making them difficult to spot against the vast backdrop of space. Oumuamua, for instance, was only a few hundred feet long, and it wasn't until it was already moving away from the sun that scientists realized it was something extraordinary. To improve their chances of finding these fleeting visitors, astronomers are constantly refining their techniques. They're developing more sensitive telescopes, like the upcoming Viera C. Rubin Observatory, which will scan the entire sky every few nights. They're also using artificial intelligence to sift through the mountains of data collected by these telescopes, helping to identify potential interstellar objects more quickly and accurately. Despite the challenges, the search for interstellar objects is a thrilling endeavor. Each discovery offers a rare glimpse into the workings of other star systems, and every new visitor brings with it the potential to reshape our understanding of the universe. As we continue to refine our methods and expand our reach, the question isn't just how we detect these objects, it's also what we might find next. With every new discovery, we're reminded that the cosmos is full of surprises, and that the next interstellar visitor could be just around the corner. Now, let's explore the role of citizen scientists in this cosmic quest, and how everyday stargazers are contributing to the search for these extraordinary objects. While professional astronomers and advanced telescopes play a crucial role in the search for interstellar objects, there's another group of sky watchers making significant contributions: citizen scientists. These amateur astronomers and space enthusiasts are proving that you don't need a PhD or access to a multi-million-dollar observatory to make a difference in the field of space exploration. One of the most remarkable aspects of citizen science is its collaborative nature. Projects like the Zooniverse platform allow everyday people to analyze real astronomical data, helping to identify potential interstellar objects or other cosmic anomalies. By sifting through images and data collected by professional telescopes, these volunteers have become an essential part of the discovery process. For instance, in some cases, it's been the sharp eyes of amateur astronomers that first spotted unusual objects, prompting further investigation by professionals. Take the case of Comet Borisov, for example. While it was initially detected by a professional astronomer, its trajectory and characteristics were later confirmed and refined with the help of observations from amateur stargazers around the world. These contributions are invaluable as they provide additional data points that help scientists piece together the full story of these interstellar visitors. Citizen scientists also play a key role in monitoring the night sky for transient events, sudden changes or movements that could indicate the presence of an interstellar object. Many amateur astronomers use their own telescopes to scan the skies, often capturing images or data that professionals might miss. This grassroots approach to astronomy creates a vast network of observers, increasing the chances of spotting something extraordinary. What makes this collaboration so powerful is its inclusivity. Anyone with an interest in space can participate, whether they're using a backyard telescope or simply analyzing data on their computer. This democratization of science not only accelerates discoveries, but also fosters a deeper connection between the public and the cosmos. The impact of citizen scientists goes beyond just finding objects. They also help raise awareness about the importance of interstellar research, inspiring others to look up at the night sky with curiosity and wonder. By contributing their time and passion, these amateur astronomers remind us that space exploration is a shared human endeavor, one that thrives on curiosity, collaboration, and the collective desire to understand the universe. As we look to the future, the role of citizen scientists will only grow, with more powerful telescopes and advanced tools becoming accessible to the public. The potential for new discoveries is immense. The next interstellar visitor might just be spotted by someone with a telescope in their backyard, proving once again that the search for cosmic mysteries is a journey we can all be a part of. Now, let's turn our attention to why these interstellar objects are so important and what they can teach us about the universe beyond our solar system. Interstellar objects are more than just fleeting visitors from distant star systems. They are cosmic messengers, carrying secrets about the universe far beyond our solar system. By studying these objects, scientists can uncover clues about how other star systems form and evolve. Each interstellar visitor is like a time capsule, preserving materials and conditions from its place of origin. This gives us a rare opportunity to analyze the building blocks of planets, stars, and even life itself, without ever leaving our own cosmic neighborhood. One of the most exciting aspects of interstellar objects is their potential to reveal the diversity of the universe. Unlike objects within our solar system, which share a common origin, these visitors come from entirely different star systems. By examining their composition, scientists can compare them to what we know about our own solar system, shedding light on whether our cosmic neighborhood is unique or just one of many similar systems scattered across the galaxy. These objects also offer a glimpse into the processes that shape planetary systems. For example, some interstellar objects may have been ejected from their home systems during chaotic events, such as the formation of giant planets or the collision of celestial bodies. By studying their trajectories and properties, we can piece together the history of these distant systems and better understand the forces that drive planetary formation and destruction. Another intriguing possibility is that interstellar objects could carry materials from other worlds, including organic molecules or even microbial life. This idea, known as panspermia, suggests that life might be spread across the universe by objects like comets or asteroids. While this remains speculative, the discovery of complex organic molecules on interstellar objects would be a groundbreaking step toward understanding the origins of life in the cosmos. Beyond their scientific value, interstellar objects also inspire us to think bigger. They remind us that our solar system is just a small part of a vast, interconnected universe. Each time we detect one of these visitors, it's a humbling reminder of how much we have yet to learn about the cosmos. As we continue to study these objects, we're not just uncovering the secrets of distant star systems, we're also expanding our understanding of our place in the universe. And with every new discovery, we come one step closer to answering some of the most profound questions about the origins of life, the diversity of planetary systems, and the nature of the cosmos itself. Now, let's explore the theories about where these interstellar objects come from and what their origins might tell us about the universe. Now, let's turn our attention to the fascinating theories about where these interstellar objects might originate. One of the leading ideas is that these objects are debris ejected from other planetary systems. Imagine a young star system, still in the process of forming planets. As giant planets like Jupiter or Saturn take shape, their immense gravitational pull can fling smaller objects like comets or asteroids out of their orbits and into the void of interstellar space. These ejected objects then drift for millions or even billions of years, eventually passing through our solar system as interstellar visitors. Another compelling theory suggests that some interstellar objects could be remnants of ancient cosmic events, such as the collision of planets or the explosive deaths of stars. For instance, when a star goes supernova, it can hurl fragments of its planetary system into space at incredible speeds. These fragments, now free-floating, might eventually cross paths with other star systems, including our own. Similarly, the collision of two planets or large asteroids could produce debris that escapes its home system, becoming an interstellar traveler. There's also the intriguing possibility that some interstellar objects might originate from regions of space we've yet to fully understand. For example, they could come from the Oort cloud of another star system, a distant, icy reservoir of comets and other small bodies. If disturbed by a passing star or another gravitational influence, these objects could be sent on a journey across the galaxy, eventually reaching us. Each of these theories offers a unique perspective on the origins of interstellar objects, and studying them helps us piece together the broader story of how planetary systems form and evolve. By analyzing the composition and trajectories of these visitors, scientists can test these ideas and refine our understanding of the processes that shape the cosmos. As we continue to explore these theories, one thing becomes clear: interstellar objects are not just random wanderers. They are clues to the history and diversity of the universe. And with each new discovery, we gain a deeper appreciation for the dynamic and interconnected nature of the cosmos. Next, we'll delve into the captivating question of whether these interstellar objects could carry life from one star system to another, and what that might mean for our understanding of the universe. Now, let's explore one of the most captivating questions surrounding interstellar objects. Could they carry life from one star system to another? This idea, known as panspermia, suggests that life, or the building blocks of life, might hitch a ride on these cosmic travelers, spreading across the galaxy. Imagine a tiny microbe, frozen in the icy depths of an interstellar comet, surviving the harsh conditions of space for millions of years. When that comet enters a new star system, it could deliver those microbes to a planet with the right conditions for life to take hold. Scientists have long debated the possibility of panspermia, and interstellar objects provide a fascinating avenue for this theory. Some of these objects, like comets, are rich in organic molecules, carbon-based compounds that are essential for life as we know it. If an interstellar comet were to collide with a planet, it could deposit these molecules, potentially kickstarting the development of life. Even if the object itself doesn't carry living organisms, the organic materials it contains could provide the raw ingredients needed for life to emerge. But how likely is it that life could survive such a journey? Space is an incredibly hostile environment, with extreme temperatures, radiation, and the vacuum of space itself. However, certain microbes on Earth, known as extremophiles, have shown remarkable resilience. Some can survive in freezing temperatures, high radiation, or even the vacuum of space for extended periods. If similar microbes existed elsewhere in the universe, they might be able to endure the long journey between star systems, especially if shielded within the protective layers of an interstellar object. Of course, this raises even more questions. Could life have originated elsewhere and been delivered to Earth by an interstellar visitor? Or could Earth's own life have been spread to other planets in the same way? While we don't yet have definitive answers, the study of interstellar objects offers a unique opportunity to explore these possibilities. By analyzing the composition of these visitors, scientists can search for signs of organic molecules or even microbial life, providing clues about the potential for life beyond our solar system. As we continue to uncover the mysteries of interstellar objects, the idea of panspermia reminds us of the interconnectedness of the cosmos. Life, if it exists elsewhere, might not be confined to a single planet or star system. It could be a cosmic phenomenon spreading across the galaxy on the backs of these ancient travelers. Next, we'll shift our focus to the ongoing efforts to find more interstellar visitors and the tools scientists are using to detect these elusive objects. Now, let's turn our attention to the exciting efforts underway to discover more interstellar visitors. As our understanding of these mysterious objects grows, so does our determination to find them. Scientists around the world are working tirelessly to improve our ability to detect and study these fleeting cosmic travelers, using cutting-edge technology and innovative methods. One of the most promising tools in this search is the next generation of telescopes. Instruments like the Vera C. Rubin Observatory, set to begin operations in the near future, are designed to scan the skies with unprecedented precision. This observatory will capture detailed images of the night sky every few nights, allowing astronomers to spot even the faintest and fastest moving objects. Its wide field view will make it particularly well suited for detecting interstellar visitors, which often appear suddenly and move quickly across the sky. In addition to ground-based telescopes, space missions are also playing a crucial role. The European Space Agency's Comet Interceptor mission, for example, is specifically designed to study interstellar objects up close. Scheduled for launch in the coming years, this mission will position a spacecraft in a strategic location, ready to intercept and analyze any interstellar object that enters our solar system. By studying these objects at close range, scientists hope to uncover new details about their composition, structure, and origins. But the search for interstellar visitors isn't limited to large-scale projects. Amateur astronomers and citizen scientists continue to make valuable contributions. With the help of powerful software and online platforms, anyone with a telescope and a passion for the stars can join the hunt. These dedicated individuals often spot objects that professional observatories might miss, proving that the search for interstellar visitors is truly a collaborative effort. As technology advances, so do our chances of finding more of these cosmic wanderers. Future missions and telescopes will not only improve our detection capabilities, but also allow us to study these objects in greater detail than ever before. Each new discovery brings us closer to understanding the nature of interstellar objects and their role in the broader cosmos. With every passing year, the search for interstellar visitors becomes more exciting and more promising. As we continue to explore the skies, who knows what incredible discoveries await us? Perhaps the next interstellar object will reveal secrets about the origins of life, the formation of star systems, or even the possibility of other civilizations. Next, we'll delve into the challenges scientists face when studying these elusive objects and how they're working to overcome them. While the search for interstellar objects is filled with excitement and promise, it's not without its challenges. Studying these cosmic visitors is no easy task, and scientists face a number of hurdles that make their work both demanding and fascinating. One of the biggest challenges is the incredible speed at which interstellar objects travel. Unlike objects within our solar system, which move at predictable speeds, interstellar visitors often zip through space at tens of thousands of miles per hour. This makes them incredibly difficult to track and observe. By the time astronomers spot one, it's often already on its way out of our solar system, leaving only a brief window for study. Distance is another major obstacle. Interstellar objects originate from other star systems, meaning they've traveled vast distances before reaching us. By the time they arrive, they're often faint and hard to detect, even with the most advanced telescopes. Their great distance also means that the light we receive from them is limited, making it tough to gather detailed information about their composition, structure, or surface features. Adding to the complexity is the limited time these objects spend in our solar system. Most interstellar visitors pass through quickly, sometimes staying for just a few months or even weeks. This short time frame leaves scientists scrambling to gather as much data as possible before the object disappears from view. It's a race against time, requiring precise coordination between observatories and space agencies around the world. Another challenge lies in the unpredictable nature of these objects. Unlike comets or asteroids from our own solar system, interstellar visitors don't follow predictable orbits. Their paths are often influenced by the gravitational pull of the sun and planets, making it difficult to predict where they'll go next. This unpredictability adds an extra layer of difficulty to planning observations or missions aimed at studying them. Despite these challenges, scientists are finding innovative ways to overcome them. Advances in telescope technology, such as the Vera-C Rubin Observatory, are improving our ability to detect faint and fast-moving objects. Space missions like the Comet Interceptor are being designed to respond quickly to new discoveries, giving us a better chance to study these objects up close. And the growing role of citizen scientists is helping to expand the search, bringing fresh eyes and new perspectives to the hunt. As we continue to push the boundaries of what's possible, each challenge we overcome brings us closer to unraveling the mysteries of interstellar objects. These cosmic wanderers may be elusive, but their secrets are worth the effort. Next, we'll explore how future space missions are shaping the way we study these fascinating visitors from beyond our solar system. Now, let's turn our attention to the exciting role that space missions play in unlocking the secrets of interstellar objects. While telescopes on Earth provide valuable data, there's no substitute for getting up close and personal with these cosmic travelers. That's where space missions come in, offering a unique opportunity to study these objects in unprecedented detail. One of the most promising missions on the horizon is the European Space Agency's Comet Interceptor. Unlike traditional missions that target specific objects years in advance, the Comet Interceptor is designed to be agile and responsive. It will wait in space, ready to spring into action when a new interstellar object is discovered. Once a target is identified, the spacecraft will intercept it, capturing high-resolution images, analyzing its composition, and even studying its interaction with the solar wind. This approach allows scientists to gather data that would be impossible to obtain from Earth, giving us a clearer picture of what these objects are made of and where they come from. But the Comet Interceptor isn't the only mission with interstellar ambitions. NASA and other space agencies are also exploring ways to study these objects more closely. For example, missions equipped with advanced spectrometers and cameras could analyze the chemical makeup of interstellar visitors, revealing clues about the conditions in their home star systems. Some proposals even suggest sending small probes to land on these objects, collecting samples that could be returned to Earth for further study. These missions are not without their challenges, of course. Interstellar objects move quickly and unpredictably, making it difficult to plan and execute a successful encounter. Spacecraft must be designed to travel at high speeds and adapt to changing conditions, all while carrying the sophisticated instruments needed to gather meaningful data. But the potential rewards are immense. By studying these objects up close, we could learn about the building blocks of other star systems, the processes that shape planetary formation, and even the possibility of life beyond our solar system. As we look to the future, it's clear that space missions will play a crucial role in advancing our understanding of interstellar objects. These missions represent the next frontier in space exploration, offering a chance to explore the unknown and uncover the secrets of the cosmos. And with each new discovery, we move one step closer to answering some of the biggest questions about our place in the universe. Next, we'll delve into what interstellar objects can tell us about the conditions and composition of distant star systems, and how these insights are reshaping our understanding of the cosmos. Now, let's explore what interstellar objects can reveal about the distant star systems they come from. These cosmic travelers are like messengers from faraway worlds, carrying with them clues about the environments and processes that shape them. By studying their composition, structure, and behavior, scientists can piece together a picture of what conditions are like in other parts of the galaxy. For example, the chemical makeup of an interstellar object can tell us about the types of materials present in its home star system. Elements like carbon, oxygen, and nitrogen, as well as more complex molecules, can provide insights into the building blocks of planets and even the potential for life. When scientists analyzed Comet Borisov, they found that its composition was surprisingly similar to comets in our own solar system. This suggests that the processes that form comets might be universal, occurring in star systems across the galaxy. But interstellar objects can also reveal differences. Some may contain materials or isotopes that are rare or absent in our solar system, hinting at unique conditions in their places of origin. For instance, if an object has a high concentration of certain metals or unusual ratios of elements, it could indicate that its star system experienced different types of stellar activity or planetary formation processes. These variations help us understand the incredible diversity of star systems and the many ways planets, comets, and asteroids can form. Another fascinating aspect is the physical structure of these objects. The elongated shape of Oumuamua, for example, sparked debates about how such a form could arise. Was it shaped by intense gravitational forces, or did it form through a unique process in its home system? By studying these features, scientists can infer the kinds of forces and events that occur in other star systems, from collisions to tidal interactions. Interstellar objects also offer a glimpse into the dynamic nature of star systems. Many of these objects are likely ejected from their home systems due to gravitational interactions, such as close encounters with massive planets or even passing stars. By tracing their trajectories and understanding their origins, we can learn about the chaotic processes that shape planetary systems over time. This helps us build a broader understanding of how star systems evolve and interact with one another. In essence, interstellar objects are like cosmic time capsules, preserving information about the environments they came from. Each one we study adds a new piece to the puzzle, helping us map out the diversity and complexity of the universe. As we continue to discover and analyze these visitors, we gain a deeper appreciation for the vast array of conditions and processes that exist beyond our solar system. Next, we'll dive into the intriguing possibility that some interstellar objects might not be natural at all, but rather artifacts from advanced civilizations. Could these objects be more than just rocks and ice? Let's explore the speculative and exciting ideas surrounding artificial interstellar objects. Now, let's turn our attention to a fascinating and speculative idea: the possibility that some interstellar objects might not be natural at all. Could these cosmic visitors be artificial, crafted by advanced civilizations far beyond our own? This concept, while speculative, opens up a world of intriguing possibilities and challenges our understanding of the universe. Imagine for a moment that an interstellar object like Oumuamua isn't just a rock or a comet, but a piece of technology. Some scientists have suggested that its unusual shape and unexpected acceleration could be signs of artificial origin. While this idea remains highly debated, it raises important questions. If such an object were artificial, what might its purpose be? Could it be a probe sent to explore other star systems, or perhaps even a message in a bottle drifting through the cosmos? The implications of discovering an artificial interstellar object would be profound. For one, it would confirm that we are not alone in the universe. It would also suggest that advanced civilizations are capable of creating technology that can travel across vast interstellar distances, surviving the harsh conditions of space for potentially millions of years. This would revolutionize our understanding of what is possible, both technologically and biologically. But how would we even determine if an object is artificial? Scientists would look for specific clues, such as unusual materials, geometric shapes, or signs of propulsion systems. For example, if an object were emitting signals or had a surface that reflected light in a way that suggested it was manufactured, these would be strong indicators. However, distinguishing between natural and artificial origins is no easy task, especially when dealing with objects that are millions or even billions of years old. The idea of artificial interstellar objects also ties into broader questions about the search for extraterrestrial intelligence. If such objects exist, they could be part of a larger network of probes or artifacts scattered throughout the galaxy. Some theories even suggest that advanced civilizations might use these objects to communicate or share knowledge across the stars. While this remains speculative, it highlights the potential for interstellar objects to serve as more than just cosmic debris. They could be keys to unlocking the mysteries of intelligent life beyond Earth. Of course, the discovery of an artificial interstellar object would also raise ethical and philosophical questions. How should we respond to such a find? Should we attempt to communicate with it, or would it be wiser to observe and study it from a distance? These are questions that scientists, ethicists, and policymakers would need to grapple with, as they would have far-reaching implications for humanity's place in the cosmos. As we continue to search for and study interstellar objects, the possibility of finding something artificial remains one of the most exciting and thought-provoking prospects. Whether natural or artificial, these visitors from other star systems remind us of the vastness and mystery of the universe and the endless potential for discovery that lies ahead. Next, we'll explore the ethical considerations of studying and potentially interacting with interstellar objects, and what it means for humanity's role in the cosmos. As we venture deeper into the mysteries of interstellar objects, it's important to pause and consider the ethical dimensions of our exploration. The idea of studying, or even interacting with visitors from other star systems, raises complex questions that go beyond science and touch on our responsibilities as explorers of the cosmos. One of the most pressing ethical concerns is the risk of contamination. If an interstellar object were to carry microbial life or organic molecules, our attempts to study it could inadvertently introduce Earth-based contaminants. This could compromise the integrity of the object and any potential extraterrestrial materials it might contain. Scientists must carefully balance the desire to learn with the need to preserve these cosmic artifacts in their natural state. After all, these objects could hold clues not just about other star systems, but about the origins of life itself. On the flip side, there's also the question of how interstellar objects might affect us. If an object were found to carry unknown substances or organisms, could it pose a risk to Earth's environment or even to human health? While the likelihood of such a scenario is low, it's a possibility that can't be ignored. This raises the need for strict protocols to ensure that any interaction with interstellar objects is conducted safely and responsibly. Another ethical consideration is the preservation of these objects as part of the cosmic heritage. Interstellar objects are rare and precious, offering us a glimpse into the workings of other star systems. Should we treat them as scientific specimens to be analyzed and dissected, or as irreplaceable artifacts to be protected and studied from a distance? This debate echoes similar discussions in fields like archaeology and paleontology, where the balance between discovery and preservation is constantly being negotiated. Then there's the question of how we might respond if an interstellar object were found to be artificial. Should we attempt to communicate with it, or would it be wiser to observe it passively? The potential discovery of an object created by an advanced civilization would be one of the most profound moments in human history, but it would also come with immense responsibility. How we choose to engage or not engage could have far-reaching consequences, not just for science, but for humanity's place in the universe. These ethical dilemmas remind us that the search for interstellar objects is about more than just scientific discovery. It's about understanding our role as stewards of knowledge and explorers of the unknown. As we continue to push the boundaries of what we know, we must also consider the impact of our actions, both on the objects we study and on the broader cosmic environment. With these ethical questions in mind, let's now turn to the future of interstellar object research and the exciting possibilities that lie ahead. As we look ahead, the future of interstellar object research is brimming with possibilities, driven by rapid advancements in technology and our growing curiosity about the cosmos. One of the most exciting developments on the horizon is the launch of next-generation telescopes like the Vera C. Rubin Observatory and the James Webb Space Telescope. These instruments will significantly enhance our ability to detect and study interstellar objects, even those that are faint or moving at incredible speeds. With their unprecedented sensitivity, we may soon discover dozens, or even hundreds, of these cosmic visitors, each offering a unique window into the diversity of the universe. Another promising area is the development of space missions specifically designed to intercept and study interstellar objects up close. The European Space Agency's Comet Interceptor mission, for example, aims to position a spacecraft in a strategic orbit, ready to rendezvous with an interstellar object as it passes through our solar system. Such missions could provide us with detailed data about the composition, structure, and origins of these objects, answering questions that ground-based observations alone cannot address. Imagine the thrill of seeing high-resolution images of an interstellar comet or asteroid, or even analyzing samples from its surface. Artificial intelligence and machine learning are also set to revolutionize this field. By sifting through vast amounts of astronomical data, these tools can help identify interstellar objects more efficiently than ever before. They can spot subtle patterns or anomalies that might otherwise go unnoticed, accelerating the pace of discovery. This collaboration between human ingenuity and cutting-edge technology could unlock secrets about the formation of other star systems, the distribution of organic molecules in the galaxy, and even the potential for life beyond Earth. Beyond technology, the future of interstellar object research will also depend on international collaboration. Space exploration has always been a global endeavor, and studying these visitors from other star systems will require the combined efforts of scientists, engineers, and institutions from around the world. By pooling resources and expertise, we can tackle the challenges of detecting, tracking, and analyzing these elusive objects more effectively. This spirit of cooperation not only advances science, but also reminds us of our shared humanity and our collective quest to understand the universe. Perhaps the most thrilling prospect is the potential for groundbreaking discoveries. What if we find an interstellar object that carries evidence of extraterrestrial life? Or one that reveals entirely new types of materials or processes not seen in our solar system? Each new discovery could reshape our understanding of the cosmos and our place within it. The future of interstellar object research is not just about answering the questions we have today. It's about uncovering mysteries we haven't even imagined yet. As we stand on the brink of this new era, one thing is clear: the search for interstellar objects is far from over. With every technological leap and every new discovery, we move closer to unraveling the secrets of the universe. And who knows, the next interstellar visitor might just hold the key to unlocking one of the greatest mysteries of all. Now, let's explore how interstellar objects have captured the imagination of popular culture, shaping the way we think about the cosmos and our place within it. Interstellar objects have long fascinated not only scientists, but also storytellers, artists, and creators across the globe. Their mysterious nature and otherworldly origins have made them a compelling subject in popular culture, inspiring countless depictions in movies, books, and other forms of media. These portrayals often shape how we imagine the cosmos and our place within it, blending scientific curiosity with creative imagination. One of the most iconic examples is the 1977 science fiction film Close Encounters of the Third Kind, where an alien spacecraft, possibly an interstellar object, becomes the centerpiece of humanity's first contact with extraterrestrial life. The film captures the awe and wonder that interstellar objects evoke, portraying them as gateways to the unknown. Similarly, in Arthur C. Clarke's novel Rendezvous with Rama, a massive cylindrical interstellar object enters our solar system, sparking a mission to explore its secrets. The story delves into themes of discovery and the limits of human understanding, reflecting the real-world fascination with these cosmic visitors. More recently, the discovery of Oumuamua inspired a wave of creative interpretations. Some speculated it could be an alien probe, a notion that found its way into books and documentaries, blurring the line between science and speculation. This idea was even echoed in popular science discussions, showing how interstellar objects can ignite both scientific debate and imaginative storytelling. These portrayals often influence public perception of space exploration by presenting interstellar objects as mysterious and potentially significant. Media can spark curiosity and inspire a deeper interest in astronomy. For instance, films like Arrival, which explores the complexities of communicating with an alien intelligence, encourage viewers to think about the broader implications of discovering interstellar visitors. Such stories remind us that the search for these objects isn't just about science, it's about understanding our place in the universe and the possibilities that lie beyond our solar system. At the same time, popular culture can sometimes oversimplify or sensationalize the science behind interstellar objects. While this can make the topic more accessible, it also highlights the importance of clear communication from scientists to separate fact from fiction. By bridging the gap between entertainment and education, we can foster a more informed and inspired public, eager to learn about the real discoveries being made in the field of astronomy. As we continue to explore the cosmos, the interplay between science and storytelling will remain a powerful force. Interstellar objects, with their enigmatic origins and fleeting presence, will undoubtedly continue to captivate our imaginations, both on the screen and in the stars. And with each new discovery, we'll find fresh inspiration to keep looking up and wondering what else might be out there. Now, let's turn our attention to the role of mathematics in predicting the paths of these interstellar visitors and how it helps us prepare for their arrival. Mathematics plays a crucial role in our ability to predict the paths of interstellar objects, acting as the backbone of modern astronomy. When an interstellar visitor like a Oumuamua or comet Borisov is detected, scientists rely on complex mathematical models to determine its trajectory. These models take into account factors like the object's speed, direction, and the gravitational forces exerted by the Sun and planets. By analyzing these variables, astronomers can predict where the object is headed and how long it will remain visible from Earth. One of the key tools used in this process is orbital mechanics, a branch of physics that applies mathematical principles to understand the motion of celestial bodies. Using equations derived from Newton's laws of motion and gravity, scientists can calculate the precise path an interstellar object will follow as it travels through our solar system. These calculations are essential for planning observational campaigns, as they help astronomers decide when and where to point their telescopes for the best chance of studying the object. Simulations also play a vital role in this process. By creating digital models of the solar system, researchers can simulate the journey of an interstellar object and test different scenarios. For example, they might explore how the object's path could change if it passes close to a planet, or if it experiences outgassing, like Oumuamua did. These simulations allow scientists to refine their predictions and prepare for unexpected behaviors, ensuring they don't miss critical opportunities to observe these fleeting visitors. The accuracy of these predictions depends on the quality of the data collected. When an interstellar object is first detected, astronomers have only a limited amount of information to work with. As more observations are made, the data is fed back into the models, allowing for increasingly precise calculations. This iterative process is a testament to the power of mathematics in unlocking the secrets of the cosmos. Beyond predicting trajectories, mathematics also helps astronomers plan future missions to study interstellar objects. For instance, the European Space Agency's Comet Interceptor mission relies on mathematical models to identify potential targets and plot the spacecraft's course. By combining real-time data with advanced simulations, scientists can ensure the mission is well prepared to intercept an interstellar object as it passes through our solar system. The role of mathematics in this field is not just about crunching numbers, it's about turning raw data into meaningful insights. Each calculation brings us closer to understanding the nature of these mysterious visitors and the stories they carry from distant star systems. As we continue to refine our models and improve our observational techniques, mathematics will remain an indispensable tool in the search for interstellar objects, guiding us as we explore the vast and uncharted reaches of the universe. Now, let's consider how these interstellar objects might impact planetary systems and what their presence could mean for the cosmic environments they encounter. Now, let's turn our attention to the broader implications of interstellar objects and how their journeys might influence the cosmic landscapes they encounter. When an interstellar object passes through a planetary system, it doesn't just drift silently by, it can leave a lasting mark on the environment it traverses. These visitors, though often small in size, carry the potential to shape the destiny of the worlds they encounter, whether through subtle gravitational interactions or dramatic collisions. One of the most significant ways interstellar objects can impact planetary systems is through their gravitational influence. Even if an object doesn't collide with a planet, its presence can subtly alter the orbits of nearby bodies. For example, a massive interstellar object passing close to a planet could nudge it slightly, changing its trajectory over time. These small shifts might seem insignificant at first, but over millions of years, they can lead to major changes in the stability and structure of a planetary system. In some cases, this could even result in planets being ejected from their orbits, sent spiraling into space or into new paths around their star. Collisions, on the other hand, are far more dramatic and immediate in their effects. Imagine an interstellar object, perhaps a comet or asteroid, slamming into a planet. The energy released from such an impact could be catastrophic, reshaping the planet's surface and atmosphere. We've seen evidence of this in our own solar system, where impacts have left massive craters and even contributed to mass extinctions. If an interstellar object were to collide with a planet in another star system, it could trigger similar events, altering the planet's climate, geology, and even its potential to support life. But it's not just planets that are affected. Interstellar objects can also influence smaller bodies like moons, asteroids, and comets. A close encounter with an interstellar visitor could disrupt the delicate balance of a system's asteroid belt, sending debris flying in new directions. This could lead to increased collisions among smaller bodies, or even create new opportunities for planets to capture moons or rings. In this way, interstellar objects act as cosmic sculptors, reshaping the environments they pass through in ways that can last for eons. Beyond their physical effects, interstellar objects also carry valuable information about the conditions of their home star systems. By studying the composition of these objects, scientists can learn about the materials present in other parts of the galaxy. For instance, if an interstellar object contains rare minerals or organic molecules, it could provide clues about the processes that shaped its origin system. This knowledge not only helps us understand the diversity of the universe, but also sheds light on how planetary systems form and evolve over time. The role of interstellar objects in shaping cosmic environments is a reminder of the interconnectedness of the universe. These travelers, born in distant star systems, carry with them the potential to influence worlds far beyond their own. Whether through subtle gravitational nudges or dramatic collisions, they leave their mark on the cosmic canvas, contributing to the ever-changing tapestry of the universe. As we continue to study these mysterious visitors, we gain not only a deeper understanding of their origins, but also a greater appreciation for the dynamic and interconnected nature of the cosmos. Next, let's explore the fascinating world of interstellar dust and how these tiny particles reveal secrets about the vast spaces between the stars. Now, let's turn our gaze to something much smaller, yet equally fascinating: interstellar dust. While interstellar objects like Oumuamua and comet Borisov capture our attention with their size and mystery, interstellar dust plays a quieter but equally important role in the cosmic story. These tiny particles, often no larger than a grain of sand, drift through the vast emptiness of space, carrying secrets about the environments they come from and the spaces they traverse. Unlike their larger counterparts, interstellar dust particles are so small that they're almost invisible to the naked eye. Yet, despite their size, they are incredibly abundant, filling the spaces between stars in what we call the interstellar medium. This medium is the cosmic fabric that makes up much of the galaxy, and interstellar dust is one of its key components. These particles are made up of a mix of elements, including carbon, silicon, and even organic compounds, which can tell us a great deal about the chemistry of the universe. One of the most intriguing aspects of interstellar dust is how it interacts with light. When starlight passes through a cloud of interstellar dust, the dust scatters and absorbs some of the light, creating effects like the reddening of stars or the dark patches we see in the night sky. This phenomenon not only helps astronomers map the distribution of dust in the galaxy, but also provides clues about the size and composition of the particles themselves. By studying how light interacts with dust, scientists can piece together a picture of the interstellar medium and the processes that shape it. Interstellar dust also plays a crucial role in the formation of stars and planets. These tiny particles act as the building blocks for larger structures, clumping together over time to form dense clouds that eventually collapse under gravity to give birth to new stars. In fact, without interstellar dust, the universe as we know it might look very different. These particles provide the raw materials needed for star formation and even contribute to the creation of complex molecules, some of which are essential for life. But interstellar dust isn't just a passive participant in the cosmos, it's also a dynamic force. As these particles move through space, they can collide with one another, exchanging energy and altering their paths. This constant motion helps distribute elements throughout the galaxy, enriching different regions with the materials needed for star and planet formation. In this way, interstellar dust acts as a cosmic recycler, spreading the building blocks of life across the universe. Studying interstellar dust also gives us a glimpse into the history of the galaxy. Because these particles are so small and lightweight, they can be carried vast distances by stellar winds or supernova explosions. This means that the dust we observe today might have originated in a star system far, far away, carrying with it a record of its journey through space. By analyzing the composition of interstellar dust, scientists can trace its origins and learn about the events that shaped its path. The search for interstellar dust is a reminder that even the smallest things in the universe can have a big impact. These tiny particles, often overlooked in favor of larger, more dramatic objects, are essential to understanding the cosmos. They reveal the hidden workings of the interstellar medium, contribute to the formation of stars and planets, and carry the history of the galaxy within them. As we continue to study these microscopic travelers, we uncover not only the secrets of the universe, but also the intricate connections that bind it all together. Next, let's explore how interstellar objects might hold clues to one of the greatest mysteries of the cosmos, dark matter. Now, let's venture into one of the most enigmatic realms of the cosmos, dark matter and explore how interstellar objects might hold clues to this invisible force that shapes our universe. While interstellar objects like Oumuamua and comet Borisov have captured our attention, and interstellar dust has revealed the hidden workings of the galaxy, dark matter remains one of the greatest mysteries in modern science. It's a substance that doesn't emit, absorb, or reflect light, making it invisible to our telescopes, yet its gravitational effects are undeniable. So, how might interstellar objects help us unravel this cosmic puzzle? One intriguing possibility is that interstellar objects could act as cosmic messengers, carrying traces of dark matter or interacting with it in ways we're only beginning to understand. For instance, some scientists speculate that dark matter might influence the trajectories of interstellar objects as they travel through space. While we can't see dark matter directly, its gravitational pull could subtly alter the paths of these objects, leaving behind clues for astronomers to decode. By studying the unusual movements of interstellar visitors, researchers might uncover patterns that point to the presence of dark matter in their paths. Another fascinating idea is that interstellar objects themselves could be made of or contain dark matter. While this is highly speculative, some theories suggest that dark matter could form into dense clumps or even exotic objects that occasionally pass through our solar system. If such objects exist, they might be detectable through their gravitational effects, even if they remain invisible to our instruments. The search for these hypothetical dark matter objects could open up entirely new avenues for understanding this elusive substance. Interstellar dust, too, might play a role in the dark matter mystery. Some researchers propose that dark matter particles could interact with the tiny particles of interstellar dust, leaving behind faint signatures that could be detected with advanced instruments. While these interactions would be incredibly subtle, they could provide a new way to study dark matter indirectly. By analyzing the composition and behavior of interstellar dust, scientists might uncover hints about how dark matter behaves on a microscopic scale. The connection between interstellar objects and dark matter also extends to the broader structure of the universe. Dark matter is thought to form a vast, invisible web that holds galaxies together and shapes the large-scale structure of the cosmos. Interstellar objects, as they travel through this web, could help us map its distribution and density. For example, if an interstellar object's trajectory deviates unexpectedly, it might indicate the presence of a dense region of dark matter. Over time, tracking these deviations could help astronomers build a more detailed picture of the dark matter landscape. Of course, these ideas are still in the realm of speculation, and much remains to be discovered. But the potential connection between interstellar objects and dark matter highlights the interconnected nature of the universe. By studying these visitors from other star systems, we might not only learn about their origins and composition, but also gain insights into one of the most profound mysteries of the cosmos. As we continue to explore the universe, the search for dark matter and the study of interstellar objects will likely remain intertwined. Each new discovery brings us closer to understanding the invisible forces that shape our reality. And who knows, perhaps one day, an interstellar object will provide the key to unlocking the secrets of dark matter, revealing a hidden layer of the universe we've only just begun to imagine. Next, let's turn our attention to how artificial intelligence is revolutionizing the search for interstellar objects, opening up new possibilities for discovery. Now, let's shift our focus to a groundbreaking tool that's transforming the way we explore the cosmos: artificial intelligence. In the search for interstellar objects, the sheer volume of data generated by telescopes and observatories can be overwhelming. This is where artificial intelligence steps in, offering a powerful way to sift through mountains of information and uncover hidden gems that might otherwise go unnoticed. Artificial intelligence, or AI, is particularly well suited for this task because of its ability to process and analyze vast amounts of data at incredible speeds. Traditional methods of detecting interstellar objects often rely on manual observation and analysis, which can be time-consuming and prone to human error. But with AI, algorithms can quickly scan through thousands of images, identifying potential candidates for further study in a fraction of the time. This not only speeds up the discovery process, but also increases the chances of finding rare and elusive interstellar visitors. One of the key ways AI is making an impact is through machine learning, a subset of AI that allows systems to improve their performance over time by learning from data. For example, astronomers can train machine learning models using known examples of interstellar objects, teaching the system to recognize similar patterns in new data. As the model encounters more examples, it becomes better at distinguishing between ordinary objects, like asteroids or comets, and those that may have originated from beyond our solar system. This ability to learn and adapt makes machine learning an invaluable tool in the hunt for interstellar objects. AI is also helping to address one of the biggest challenges in astronomy: noise. Telescopes capture a lot of data, but not all of it is useful. Background stars, cosmic rays, and other sources of interference can obscure the signals of interstellar objects. AI algorithms can filter out this noise, isolating the faint signals that might indicate the presence of an interstellar visitor. By cleaning up the data, AI allows astronomers to focus on the most promising candidates, saving time and resources. Another exciting application of AI is in predicting the trajectories of interstellar objects. Once an object is detected, understanding its path through space is crucial for planning observations and determining its origin. AI can analyze the object's motion, taking into account factors like gravity and solar radiation pressure, to predict where it will go next. This predictive capability is especially important for fast-moving objects like Oumuamua, which pass through our solar system in a matter of weeks. By anticipating their movements, AI helps astronomers make the most of the limited time they have to study these fleeting visitors. The use of AI isn't limited to ground-based telescopes. Space missions, too, are beginning to incorporate AI to enhance their capabilities. For instance, future missions designed to study interstellar objects up close could use AI to autonomously adjust their instruments, or even make decisions about which objects to prioritize. This level of automation could revolutionize our ability to explore the cosmos, allowing us to gather more data and make discoveries faster than ever before. As we continue to push the boundaries of technology, the role of artificial intelligence in astronomy will only grow. By combining the power of AI with the expertise of human astronomers, we're opening up new possibilities for discovery and deepening our understanding of the universe. The search for interstellar objects is just one example of how AI is transforming science, and it's a reminder that the tools we create today can help us unlock the mysteries of tomorrow. Next, let's explore the cultural significance of interstellar objects and how they've inspired awe and curiosity throughout human history. Now, let's turn our gaze to the stars and consider how interstellar objects have captivated not just scientists, but the human imagination as a whole. These mysterious visitors from beyond our solar system have long been a source of wonder, sparking questions about our place in the universe and the nature of existence itself. From ancient myths to modern art, interstellar objects have woven themselves into the fabric of human culture, bridging the gap between science and the deeper questions of philosophy and spirituality. Throughout history, the appearance of unusual celestial phenomena has often been interpreted as a sign or message from the cosmos. In many cultures, comets and other transient objects in the sky were seen as omens, heralding great change or divine intervention. While we now understand that interstellar objects like Oumuamua and Comet Borisov are natural phenomena, their arrival still stirs a sense of awe and curiosity. They remind us that the universe is vast, dynamic, and full of mysteries waiting to be uncovered. This sense of wonder isn't limited to ancient beliefs. Even today, interstellar objects inspire artists, writers, and thinkers to explore themes of exploration, connection, and the unknown. Science fiction, in particular, has embraced the idea of interstellar visitors, imagining them as everything from alien probes to cosmic messengers. Stories like Arthur C. Clarke's Rendezvous with Rama, or the more recent film, Arrival, reflect our fascination with the possibility of encountering something truly alien. These narratives often delve into the philosophical implications of such encounters, asking what it means to be human in a universe that might be teeming with other forms of life. But it's not just fiction that draws inspiration from interstellar objects. Scientists and philosophers alike have pondered what these visitors might tell us about the cosmos. For some, they represent a tangible connection to other star systems, offering clues about the conditions and processes that shape distant worlds. For others, they raise profound questions about the origins of life and the possibility of its spread across the galaxy. Could interstellar objects carry the building blocks of life, or even dormant microbes, from one star system to another? These questions blur the line between science and spirituality, inviting us to consider the deeper meaning of our existence in the universe. Interstellar objects also challenge us to think beyond our own solar system. They remind us that Earth is just one small part of a much larger cosmic story. This perspective can be both humbling and inspiring, encouraging us to look beyond our immediate concerns and consider the broader tapestry of the universe. In a way, these objects serve as cosmic messengers, urging us to explore, question, and dream. As we continue to study interstellar objects, their cultural significance will only grow. They are more than just scientific curiosities. They are symbols of our enduring desire to understand the universe and our place within it. Whether through art, philosophy, or science, these visitors from other star systems invite us to reflect on the mysteries of existence and the boundless possibilities that lie beyond our world. Next, let's explore the potential for interstellar object mining and the technological and ethical challenges it presents. Now, let's shift our focus to a fascinating and futuristic idea. What if we could mine interstellar objects for resources? Imagine a future where humanity ventures beyond our solar system, not just to explore, but to extract valuable materials from these cosmic travelers. The concept of mining interstellar objects might sound like science fiction, but as our technology advances, it's becoming a topic of serious discussion among scientists and space agencies. Interstellar objects like Oumuamua and comet Borisov are thought to contain a variety of materials, from metals and minerals to water ice and organic compounds. These resources could be incredibly valuable, not just for sustaining life in space, but also for fueling further exploration. For example, water extracted from an interstellar comet could be used to produce oxygen and hydrogen, essential for life support and rocket fuel. Metals and rare minerals could be used to build spacecraft or habitats, reducing the need to launch heavy materials from Earth. However, the challenges of mining interstellar objects are immense. First, there's the issue of speed and distance. These objects travel at incredible velocities, often tens of thousands of miles per hour, making it difficult to intercept them. Even if we could catch up to one, the technology required to land on or attach to such a fast-moving target is still far beyond our current capabilities. Additionally, the sheer distance these objects travel means that any mining mission would likely take years, if not decades, to complete. Then there's the question of ethics. If we were to mine an interstellar object, would we be altering something that belongs to the universe as a whole? Some argue that these objects are natural relics of other star systems, and tampering with them could erase valuable scientific information about the cosmos. Others worry about the potential for contamination. Introducing Earth-based microbes to an interstellar object, or vice versa, could have unforeseen consequences for both our planet and any potential extraterrestrial ecosystems. Another consideration is the legal framework. Currently, space law is governed by treaties like the Outer Space Treaty of 1967, which states that celestial bodies cannot be claimed by any nation. But what about objects that are just passing through? Would mining an interstellar object be considered exploitation of a celestial body, or would it fall under a different category? These are questions that will need to be addressed as the idea of interstellar mining becomes more feasible. Despite these challenges, the potential rewards are hard to ignore. Mining interstellar objects could provide humanity with the resources needed to expand our presence in space, making long-term missions and even colonization more sustainable. It could also open up new avenues for scientific discovery, allowing us to study materials that originated in other star systems up close. As we look to the future, the idea of mining interstellar objects invites us to think big, not just about what we can achieve, but about the responsibilities that come with exploring and utilizing the cosmos. It's a reminder that our journey into space is not just about discovery, but also about stewardship. And as we continue to push the boundaries of what's possible, these cosmic visitors may one day become more than just objects of curiosity. They could become stepping stones to a new era of space exploration. Next, let's explore the role of international collaboration in studying interstellar objects and how global efforts are shaping our understanding of these mysterious travelers. Now, let's turn our attention to how the world is coming together to unlock the secrets of interstellar objects. The study of these cosmic visitors isn't just the work of a single nation or organization. It's a global effort that relies on collaboration across borders. International cooperation has become a cornerstone of interstellar object research, bringing together scientists, telescopes, and resources from around the world to tackle the mysteries of these fleeting travelers. One of the most notable examples of this collaboration is the discovery and tracking of Comet Borisov. When this interstellar comet was first detected in 2019, astronomers from multiple countries quickly joined forces to observe and analyze it. Telescopes in Europe, the United States, and beyond worked in unison to gather data, sharing their findings in real time. This global network of observatories allowed scientists to piece together a detailed picture of Borisov's composition, trajectory, and behavior, revealing insights that would have been impossible to achieve alone. Another key player in this international effort is the European Space Agency, which has been at the forefront of planning missions to study interstellar objects up close. Their proposed Comet Interceptor mission, set to launch in the coming years, is a prime example of how countries are pooling their expertise and resources. The mission involves contributions from scientists and engineers across Europe, Japan, and other nations, all working together to design a spacecraft capable of intercepting and studying an interstellar object as it passes through our solar system. This kind of collaboration not only spreads the cost and risk, but also ensures that the mission benefits from the best minds and technologies available worldwide. But it's not just large space agencies driving this effort. Amateur astronomers and citizen scientists have also played a crucial role in the global hunt for interstellar objects. Platforms like the International Astronomical Union's Minor Planet Center rely on contributions from observers around the world who report their findings and help track these fast-moving objects. This decentralized, community-driven approach has proven invaluable, especially when it comes to detecting interstellar visitors that might otherwise go unnoticed. The importance of international collaboration extends beyond just sharing data and resources. It also fosters a sense of unity in the pursuit of knowledge. Studying interstellar objects is a reminder that the cosmos doesn't belong to any one nation or group. These objects are messengers from distant star systems, and understanding them requires a collective effort that transcends borders. By working together, humanity can achieve far more than any single country could on its own. As we look to the future, the role of international collaboration will only grow more critical. With new telescopes like the Vera C, Rubin Observatory set to come online, the number of detected interstellar objects is expected to skyrocket. This will require even greater coordination among scientists and institutions worldwide to ensure that every discovery is thoroughly studied and understood. The challenges are immense, but so are the rewards. Together, we can unlock the secrets of these cosmic travelers and gain a deeper understanding of the universe we share. Next, we'll explore how interstellar objects might hold clues to the origins of life itself, and what their study could mean for our search for extraterrestrial intelligence. Now, let's take our journey beyond the boundaries of our own solar system and into the vast expanse of the cosmos. While much of our focus has been on interstellar objects passing through our neighborhood, scientists are also turning their attention to detecting these mysterious travelers in other star systems. This ambitious endeavor pushes the limits of our technology and imagination, offering a glimpse into the cosmic highways that connect distant worlds. One of the most promising tools in this search is the next generation of advanced telescopes. Instruments like the James Webb Space Telescope and the upcoming Extremely Large Telescope are designed to peer deeper into space than ever before. These telescopes are equipped with cutting-edge technology that allows them to detect faint signals and subtle changes in light, which could indicate the presence of interstellar objects orbiting or passing through other star systems. By analyzing these signals, astronomers hope to identify objects that originated far beyond our own cosmic backyard. But detecting interstellar objects in other star systems is no easy task. These objects are often small, dark, and incredibly distant, making them extremely difficult to spot. To overcome these challenges, scientists are developing innovative observational techniques. One approach involves monitoring the light from distant stars for telltale dips or fluctuations, which could be caused by an interstellar object passing in front of the star. This method, known as transit photometry, has already been used to discover thousands of exoplanets, and it could now be adapted to hunt for interstellar visitors. Another technique relies on gravitational microlensing, a phenomenon where the gravity of a passing object bends and magnifies the light from a background star. By carefully analyzing these microlensing events, astronomers can infer the presence of interstellar objects, even if they are too faint or distant to be seen directly. This method has already yielded intriguing results, including the detection of potential rogue planets and other free-floating objects that may have been ejected from their home star systems. The search for interstellar objects beyond our solar system also benefits from the growing field of data science. With the sheer volume of data collected by modern telescopes, researchers are turning to artificial intelligence and machine learning to sift through the noise and identify potential candidates. These tools can analyze vast data sets in a fraction of the time it would take a human, helping astronomers spot patterns and anomalies that might otherwise go unnoticed. This combination of human ingenuity and technological innovation is opening new doors in our quest to understand the universe. As we expand our search to other star systems, we're not just looking for objects, we're looking for clues. Each interstellar object we detect could hold valuable information about the conditions and processes that shape other planetary systems. By studying these objects, we can learn more about the diversity of the cosmos and the forces that drive its evolution. This knowledge could even shed light on the origins of our own solar system and the building blocks of life. The search for interstellar objects beyond our solar system is a testament to humanity's curiosity and determination. It's a reminder that the universe is full of mysteries waiting to be uncovered, and that each discovery brings us one step closer to understanding our place in the cosmos. As we continue to explore, we'll not only expand our scientific knowledge, but also deepen our connection to the stars. Next, we'll delve into how interstellar objects might play a role in the search for extraterrestrial intelligence, and what their study could reveal about the possibility of life beyond Earth. Now, let's shift our gaze to an even more intriguing possibility. What if interstellar objects aren't just natural phenomena, but could also hold clues to the existence of extraterrestrial intelligence? This idea might sound like science fiction, but it's a question that scientists are seriously exploring. Interstellar objects, with their mysterious origins and journeys across the cosmos, could potentially serve as messengers or even artifacts from civilizations far beyond our own. One of the most fascinating theories is that interstellar objects might carry intentional messages or signals from advanced civilizations. Imagine an object like Oumuamua, with its unusual shape and trajectory, being more than just a rock or comet. Could it be a probe designed to communicate with other intelligent beings? While this idea remains speculative, it's not entirely outside the realm of possibility. Scientists have considered the concept of interstellar archaeology, where objects from other star systems are studied for signs of artificial construction or encoded information. Even if the chances are slim, the potential implications are profound. Another angle to consider is the possibility of interstellar objects acting as carriers of life or technology. The theory of panspermia suggests that life could spread across the universe by hitching rides on objects like comets or asteroids. If interstellar objects can transport microbial life, could they also carry more complex forms of technology or even dormant probes? Some researchers have proposed that advanced civilizations might send out self-replicating probes to explore the galaxy, and these probes could be disguised as natural objects to avoid detection. If such a probe were to pass through our solar system, it might go unnoticed unless we knew exactly what to look for. The search for extraterrestrial intelligence also benefits from the study of interstellar objects because they offer a unique opportunity to test our detection capabilities. If we can identify and analyze these objects, we might develop the tools and techniques needed to spot more subtle signs of alien technology. For example, astronomers could look for unusual patterns in an object's composition, structure, or movement that might suggest artificial origins. Even if no definitive evidence is found, the process of searching helps refine our methods and expands our understanding of what's possible. Of course, the idea of interstellar objects being linked to extraterrestrial intelligence raises important questions about how we approach such discoveries. How would we verify that an object is artificial? What protocols would we follow to study it without contaminating it or risking unintended consequences? These are challenges that scientists and ethicists are already beginning to address as the search for extraterrestrial intelligence becomes increasingly intertwined with the study of interstellar visitors. As we continue to explore the cosmos, interstellar objects remind us that the universe is full of surprises. Whether they're natural or artificial, these travelers from distant star systems hold the potential to transform our understanding of life, intelligence, and our place in the universe. And as we refine our search methods and expand our technological capabilities, we may one day find that the answers we've been seeking have been passing through our solar system all along. Next, we'll reflect on how the discovery and study of interstellar objects have shaped our understanding of the universe and inspired future generations of scientists. As we look back on the journey of interstellar object discoveries, it's clear that these cosmic visitors have left an indelible mark on our understanding of the universe. From the moment Oumuamua streaked through our solar system, sparking debates and curiosity, to the more recent observations of Comet Borisov, these objects have challenged our assumptions and expanded our horizons. They've shown us that our solar system is not an isolated bubble, but part of a much larger, interconnected cosmic neighborhood. The study of interstellar objects has also ignited a new wave of scientific curiosity and innovation. For astronomers, these visitors are like cosmic postcards, offering glimpses into the conditions and processes of distant star systems. Each object carries clues about the materials, temperatures, and even the history of its home system, providing a rare opportunity to study the universe beyond our own backyard. This has led to advancements in observational techniques, data analysis, and even the development of new technologies designed to detect and study these fleeting travelers. But perhaps the most profound impact of interstellar object discoveries lies in their ability to inspire. For scientists and dreamers alike, these objects are a reminder of how much we still have to learn about the cosmos. They've sparked imaginations, fueled debates, and even reshaped the way we think about the possibility of life beyond Earth. The idea that we might one day find evidence of extraterrestrial intelligence or even microbial life on an interstellar object has become a driving force for many researchers, pushing the boundaries of what we thought was possible. For future generations, the legacy of these discoveries is a call to explore. They serve as a testament to the power of curiosity and the importance of looking beyond our own world. As we continue to refine our tools and expand our knowledge, the study of interstellar objects will undoubtedly remain a cornerstone of astronomical research, offering endless opportunities for discovery and wonder. With this in mind, let's turn our attention to the broader implications of interstellar object research and how it might shape the future of space exploration. What new mysteries will we uncover, and how will these discoveries continue to inspire us? The answers, much like the objects themselves, are waiting to be found. As we bring our journey through the mysteries of interstellar objects to a close, let's take a moment to reflect on what we've uncovered. These cosmic visitors, from the enigmatic Oumuamua to the icy comet Borisov, have opened our eyes to the vastness of the universe and the incredible diversity of materials and processes that exist beyond our solar system. They've shown us that the cosmos is far more dynamic and interconnected than we once imagined, offering tantalizing clues about the origins of distant star systems and the potential for life elsewhere in the universe. The study of interstellar objects has not only deepened our scientific understanding, but also reignited our sense of wonder. These fleeting travelers remind us that there is still so much to discover, and that every new observation brings us closer to unraveling the secrets of the cosmos. They challenge us to think bigger, to push the boundaries of our technology, and to embrace the unknown with curiosity and determination. As we look to the future, the search for interstellar objects will continue to be a cornerstone of astronomical research. With advancements in telescopes, space missions, and data analysis, we are poised to uncover even more about these mysterious visitors and what they can teach us about the universe. Each discovery will bring new questions, new possibilities, and new opportunities to explore the cosmos in ways we've only begun to imagine. So, as we conclude this exploration, let's leave you with a question to ponder. What might the next interstellar visitor reveal about the universe and about ourselves? Could it carry evidence of life from another star system, or perhaps even a message from an advanced civilization? The answers are out there, waiting to be discovered. And as we continue to search the skies, we invite you to join us in this incredible journey of exploration and discovery. Don't forget to like, subscribe, and hit the notification bell to stay updated on the latest cosmic mysteries. Together, let's keep looking up and wondering what lies beyond the stars.